Sec 1 Mathematics Chapter 8 Part 3b Speed. Now in this part of the chapter we'll be talking about the questions in TYS, the last two questions on the notes itself, and then we'll be doing exercise 8.3, the following questions. Now get ready with your exercise book and textbook and we shall begin with our lesson. Question number 1. Now calculate the time taken for a bullet to travel 100 meters at a speed of 5,000 meters per second, given your answer in seconds. Alright, now how do we find time taken? So before we begin, we need to write out our DST. So time taken is given by distance, 100 meters, divided by the speed, 5,000 meters per second, and that will give us the answer of 0.02 seconds. Have you gotten your answer? Part B. Calculate the average speed of an insect which travels 450 cm in 1.5 minutes. Give your answer in meters per second. Now the question asks for meters per second. There's two methods to do this answer. First method will be average speed is given by distance divided by time. The distance is 450 cm and now the time is 1.5 minutes, but I'm going to change this into meters. So for cm to change to meters, 1 meter is 100 cm. Therefore, from cm to meter, I will divide by 100. So I'm going to divide by 100 to change these units to meters. And 1 minute to change from seconds to minutes to second. 1 minute has 60 seconds. So I'm going to multiply by 60 to change this to seconds. And the answer will be 0.05 meters per second. Now this is method 1. We can use a method 2 in this case. Now 450 cm in 1.5 minutes. We are first going to change the units from minutes to seconds first. So this means that this will be 1.5 times 60 will give me 90 seconds. For 450 cm, I'm going to change these units to meters. So I'm going to divide by 100 first. So this will be 4.5 meters. And then now I will find out what is 1 second. So if I want to find 1 second, that will be 1 divided by 90 times 4.5. So the answer over here will be 1 over 90 times 4.5 to give you the answer 0.05 meters. Therefore, the speed will be 0.05 meters per second. Alright, now these two methods are both acceptable, so up to you to choose the method that you prefer. Okay, part C. Light takes 2 1/4 minutes to travel from Mars to Earth. The speed of light is given to be 300,000 kilometers per second. Calculate the distance in kilometers from Mars to Earth. Now let me shift over a little bit for my question. So now what are we given? We know that to find the distance is given by speed times time. So the speed is given to be 300,000 kilometers per second. Now this is in seconds, but the time here is given in minutes. So distance equals to speed times the time. But the time now, I'm not going to use 2 1/3 minute. I'm going to change this timing into seconds. So to change this into seconds, I multiply by 60. 1 minute has 60 seconds. And that will be 140 seconds. And now we can calculate the units in terms of kilometers. And this will be the distance. That was a very, very long distance. Have you gotten your answer? Now let's move on to the next question. Okay, question number 2. John and Peter took part in a marathon race. They each ran 42 kilometers. John ran at a constant speed of x kilometers per hour. Write down an expression in terms of x for the number of hours he took. So for John's case, if I want to find the time taken, will be distance divided by time. So we use our triangle DST. So time is distance divided by speed. Distance is 42 kilometers, and then the speed is x kilometers per hour. So divide by x, and the unit for the time will be hours. Okay, and that's for part A. Now part B says Peter ran at a constant speed, which was half a kilometer less than John's speed. So half a kilometer less than John's speed, meaning for Peter, the speed is now origin x, okay, but less than John's speed. So x minus half. Okay, let us write this, okay, as kilometers per hour. Now write down an expression in terms of x for the number of hours he took. So Peter took, the time that Peter took taken will be again distance divided by speed, which is x minus 1 over 2. However, we cannot have a fraction inside another fraction. That means you'll need to think of a way to make this fraction disappear. So what can we do? What is the denominator in this case? The denominator here is 2, right? So if I want to make this fraction disappear, I'll need to multiply by 2. But I'm not going to change the numerical value of the whole fraction itself. So hence, what I need to do, if I'm going to multiply something to my denominator, I'll need to multiply it to the numerator as well, so that the value does not change. So in this case, I will have 42 times 2 to give me 84. And if I multiply the 2, I'll need to multiply it to x and the fraction half. So this will now become 2x minus half times 2 will now be 1. So this will be the new speed, new time, hours. So this will be the answer. Now let's move on to the textbook questions. Exercise 8.3, question number 2D. Now convert the following speed to meters per second. So I have question 2D. In this case, there are two ways that you can do. 16 kilometers per hour. So the speed is now, method number 1, 126 kilometers 1 hour. But now I'm going to change all the units into the correct units. So to change kilometers to meters, so kilometers to meters is times 1000. So I'm going to multiply by 1000 so that this unit is now meters. And to change hours to seconds, hour to minute to seconds, that is times 60 times 60, that gives you 3600. So times 3600 and change it to seconds. And this answer will be 35 meters per second. Question 3D. Now to take a look here, we are going to change from meters per second to kilometers per hour. So for part 3D, this is given by the speed to be 40 meters 1 second. But now we are going to change the units into kilometers per hour. To change from meters to kilometers, I'm going to divide by 1000. Okay, and then I'm going to divide by 3600. And that will be the units now, kilometers, hours. And I'll get the answer to be 144 kilometers per hour. Now, these are not the only method. There is another method for part D, question 2D. Now, if I were to do question 2D, I can see that this is 126 kilometers in 1 hour. And they want us to change to seconds. That will be 3600 seconds in, and this will change to meters, 126 meters. Now they want us to find meters per second, so we take 1 second, so we'll divide this number by 3600 to give me 35 meters in 1 second. So this means the speed will be 35 meters per second. There is actually a shortcut when you want to change from kilometers per hour to meters per second. What you can do is, I'm going to take 126 kilometers per hour. Now this is in kilometers per hour, right? If I'll change it to meters, the number will actually become smaller, isn't it? So we will take this, divide by 3.6, and then we'll get the answer to be 35 meters per second. Right? And for part 3D, there is also another shortcut, but another method first. If I were to have 40 meters in 1 second, they want us to convert it to hours, so that will be 3600 seconds. 3600 seconds times 40, that will give me 14000 meters. And now I'm changing this to kilometers, so I get 144 kilometers in 1 hour. So the time for the speed itself will be 144 kilometers per hour. Now notice that there is a shortcut as well. If I want to change from meters per second to kilometers per hour, now originally is 40 meters per second. What I can do, I will multiply by 3.6. So 40, because from meter is smaller to kilometers, it will be larger. 40.6, and it will be 144 kilometers per hour. But this working itself, this is just a shortcut, a quick way to check your answers. It will be good for you to write down answers with working. Question number 8. Jack walks at an average speed of 4 kilometers per hour for 1 hour, and then cycle for 6 kilometers at 12 kilometers per hour. Find his average speed for the total journey, for the whole journey. So there's two portions to it. We have a walking, and then we have a cycling. Okay, so for this portion, I will always look for 3 letters: D, S, and T. D, S, and T. Distance, speed, and the time. So the distance over here, I'm not very sure, but I know that Jack walks at a speed of 4 kilometers per hour, and then for 1 hour. So that means I know very obviously the distance will be 4 kilometers, right? And then he cycles 6 kilometers at a speed of 12 kilometers per hour. That means very obviously I'm going to find the time taken, distance divided by speed, which gives me half an hour. So now if I want to find the average speed for the whole journey, the total distance is equals to 4 plus 6, 10 kilometers. And the total time is equals to 1 plus half, which is 1.5 hours. Sorry. And now I want to find the average speed. So remember to write a description. So the average speed will be given by total distance over total time, and this is in kilometers per hour. So the answer will be, if I want the answer to be exact, that will be 6 to third kilometers per hour. Now this is a recurring number. Either you can write it this way, or you can write as 6.66666, which is 6 recurring. Okay, have you gotten your answer? Next question, number 9, part B. Mr. Tan ran from his home to a provision shop 400 meters away at an average speed of 2 meters per second. So first he ran from home to the provision shop. Okay, home to shop. Okay, similarly, I'm still going to look for 3 things, T, S, and T. The distance is 400 meters away, and then average speed is 2 meters per second. Okay, that means that's going to tell me that the time taken will be distance divided by speed, which is 200 seconds. Then next, if you're going to stay at the provision shop, so I say that is in for shop for 5 minutes, so stay in the shop. The distance will be 0, the speed will also be 0, the time is 5 minutes. But then if they want the average speed for the whole journey, and this is going to be measured in seconds, so 5 minutes is actually 5 times 60. That will give me 300 seconds. Right, then last but not least, now he walked from home. He walked from shop to home, right, and an average speed of 1 meters per second. Well, the distance is still the same, didn't change. The speed is now 1 meter per second, so the time taken will now be 400 divided by 1. That gives me 400 seconds. So now if I want to find the average speed for the whole journey, as I have no space to write, average speed will now be total distance. The total distance is 400 plus 0 plus 400, and that gives me 800 meters. The total time taken will be 200 seconds plus 300 seconds plus 400 seconds. 200 plus 300 plus 400, and that gives me 900 seconds. So then my answer will be 8/9 meters per second. I'll leave this answer as the exact value. Have you gotten the answer? Question number 10. Town A and B are 100 kilometers apart. So this is town A and that is town B, 100 kilometers apart. At 8 o'clock, James depart for town B from town A. So 0800 James, right? He goes from this A to B in this direction, driving at a constant speed of 60 kilometers per hour. And then at the time 8:30, so the timing 8:30. Now this means there's a total of 30 minutes, right? So what distance have James traveled? So it will be 60 times half an hour. That will give me 30 kilometers. Okay, if that's the case, that means he has a remaining journey of 70 kilometers. And then next, so he continues to move on. So he continued to move at a rate of 60 kilometers per hour in this direction. But at 8:30, Kumar departs for town A from town B. So Kumar starts from here and he starts going. This is for Kumar. And he's driving at a constant speed of 50 kilometers per hour. Now, what time will James and Kumar pass each other? Now, what is the total distance that is left? The total distance here to travel is 70. And now, James traveled at 60 and Kumar traveled at 50, but they are going towards each other. So if that's the case, what is the combined speed where they will meet together, they will travel together? So the combined speed for these two, for James and Kumar, will now be within 1 hour, James will have traveled 60 kilometers and then Kumar will have traveled 50 kilometers. So the combined speed is 110 kilometers. So if I want to find the time where they will meet each other, my remaining distance is now 70 kilometers. So time taken is distance divided by speed. So the distance is 70 kilometers and the speed is 110 kilometers per hour. Now, what can we get? This is 70 divided by 110. I'll get 7/11 of an hour. But let's change this timing because they want to find the time, right? So we're going to find this timing into minutes and seconds, or rather minutes itself. So we're going to multiply by 60 to change it to minutes. Now 7/11 times 60 will give me approximately 38 minutes. Okay, approximately, right? So I'm going to write this as the approximation sign. 38.18 actually, to be clear. So now the timing that they started to meet towards each other is from 8:30. We have a time lapse of 38 minutes. What time will that be? 8:30 plus another 30 minutes will give you 9 o'clock. 9 plus 8, that will give you 0908 hours. So this time they will meet each other at 0908 hours. Have you gotten the concept? Question 13. A train passes through a 360-meter long tunnel completely in 24 seconds. Now, what does this mean? Okay, let's take a look at the example. For example, if I were to have a train and this is a tunnel, this tunnel is 360 meters and I want to have a train. I don't know how long is this train, so maybe I'll say this is the train cabin. Okay, the train, I do not know the length, but at the start timing when it have traveled, okay, at this time when it reached the end of the tunnel of 360, this train is still inside the tunnel, right? So this 24 seconds is for it to come out completely of the tunnel. So now it means the total distance, if let's say I do not know the length of the train, I let this length of the train be x, my total distance traveled in this 24 seconds is actually 360 plus x meters. So in my question, I'm going to let the length of train be x. Okay, now it passes through this in a total of 24 seconds. So the distance is given to be 360 plus x meters. The speed I do not know, but the time taken is 24 seconds, right? So now actually I can write an expression for the speed later on. Now I pass through another tunnel, the same train, but now it's a slightly shorter tunnel. Okay, similarly, it passes through another tunnel. okay, completely. So now this train is still x meters. When it has traveled 216 meters, okay, the train is only at this position over here. So if I want to travel completely out of the tunnel, I need to add another length of the train, which is x. So the total distance traveled by the train is actually 216 plus x meters. So the distance for this second portion here will be 216 plus x meters. The speed I do not know, and the time taken is 16 seconds. Now question tells me that the same train travel at the same average speed. So in this case, from this part over here, I can find an expression for the average speed to be distance divided by time taken. So I'm going to try to use algebra as much as possible and not the model method or whichever that you have learned in your primary school. Okay, and then now the same time I need to know that this is the speed. For the second part of the journey, there will be distance divided by the time taken. So now question says that the speed are the same. So we're going to form an algebraic equation. So the algebraic equation will say that the speed at the first part of the journey is equals to the speed at the second part of the journey. And they want us to solve for the length of x. So when we have a fraction on this side, on each side, we can now cross multiply and solve the equation. Equal sign stays in the center. So I have 16 times 360 plus x, 24 times 216 plus x. Expanding our bracket, that gives us, okay, so after expansion we get this expression. Now we're going to group the like terms together. So I will keep 24x over here and bring 16 over 16x, so it'll be minus 16x, and then I'll keep 5760 over here and bring this over, so it'll be minus 5184, and this will be simplified to 576 to be equals to 8 units of x. How do I find 1 unit of x? I'll take 576 divided by 8. That gives me 72. So therefore, the length of the train will be 72 meters. Have you gotten the concept? Please try to use algebra as much as possible. Now we move on to the next question. Okay, question 14. Along a road, spot X and Y are 1,150 meters apart. So I will have one particular long road. This one X and Y. So this is 1150 meters apart. Okay, N walks along the road from X to Y. So this is N at a speed of 2/3 meters per second. Johann walks along the same road from Y to X. So Johann is over here. He walks along the same road at Y to X is 1¼ meters per second. Now both of them have the same units for speed. They both start walking at the same time. So if this is the case, what is the combined speed? They are all walking towards each other, right? So within 1 second, N has traveled 2/3 and Johann has traveled 1¼ So the combined speed for the both of them will be 2/3 plus 1¼ meters per second. That will give me 1 and 11/12 meters per second. Now question asks for how many minutes later will they meet. So time is given by distance divided by speed. So the distance is 1150, which is in meters. Divide by the time, the speed is 1 and 11 over 12, that is in seconds. And we have the number to be 600, but this is in seconds. Now question asks us for minutes. How many minutes later will they meet? So 1 minute have 60 seconds, so I'm going to divide by 60, and that will give me 10 minutes. So they will meet 10 minutes later. Part B, how far is their meeting point away from X? So away from X itself, that will be at n speed for a time of 10 minutes. So in this case, I'll just need to find the distance to be speed times time, 2 over 3 times the time taken. But I'm going to use, this speed is meters per second, so I'm going to use the 600 seconds instead of the 10 minutes. So that will give me a distance of 400 meters. Have you gotten the answer? Last question for the day. A train travels from P to Q at an average speed of 80 kilometers per hour. It returns from Q to P along the same rail at an average speed of 90 kilometers per hour. Oh dear. There is no information on distance and time. It's all just in speed. So now we have to think of a way to represent our distance and find our time taken as well. So I'm going to use algebra again. So let's say I want to travel from P to Q. The distance I do not know. The speed I know that is 80 kilometers per hour, and I do not know the time. Now it returns from Q to P, so along the same rail, so that means they share a common distance. The distance will be the same. So what I'm going to do, I'm going to let X be the distance between P and Q. Okay, so X is the distance between P and Q. If that's the case, from Q to P, my distance is also X kilometers. But the speed is now 90 kilometers per hour. And the time taken, I'll need to find. So we shall use this information to find the time taken. Time taken will be given by distance divided by the speed, which is 80 kilometers per hour, so this will be hours. And time taken for Q to P will be distance divided by the speed, that will be in hours. So they want us to find the average speed of the whole journey. That means total distance is given by X plus X. That means we'll have 2x kilometers. Total time taken will be X over 80 plus X over 90, X over 80 plus X over 90 hours. So now we are going to find the speed for the whole journey. Well, this is going to be distance divided by time, but then now we see that this is not one single fraction. So what we can do is we can combine this into one single fraction first to simplify our working later. What is the lowest common multiple for these two denominators? Now 9 times 8 will give me 72, right? So I'm going to multiply by 9 over here. I'm going to multiply by 8 over here to give me the denominator. 9 times 8, 72, 720. That will be 9x plus 8x. And it simplifies to 17x over 720 hours. So now to find the average speed, Okay, since there's a lot of fraction in this case, I shall write my answers in distance divide by time taken, total distance over total time over 720. Now, what do we do when we change a division to multiplication? The fraction over here will swap the position. So be 720 over 17x. Take note, 2x belongs to the numerator. So now we have x in the numerator and x in the denominator. We can cancel them away and we are left with the answer 1440 over 17, which we can simplify to the mixed fraction, mixed number, 8412 over 17 kilometers per hour. We'll leave this answer as exact as possible, so we prefer it in fraction and try not to leave it in decimal places. Now, have you gotten the answer? We have come to the end of this part of the chapter, and we'll be moving on to chapter 9 in the next few lessons. See ya!